my dear student, I'm Mr. Ktwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of properties of matter for the subtopic of the surface tension as we observe here. Now, before we proceed with our discussion here, we are supposed to remember where we ended on the last session. On the last session, my dear student, we tried to explain how can we measure the surface tension of the liquid using the capillarity methods. That is what we looked on the last session. Finally, we proceeded on how can we determine the angle of contact. And we said that the angle of contact, my dear student, this is the angle that is formed when due to the liquid surface and also to the solid surface of the point of contact. That is why we identify the angle of contact. We say that, my dear student, every liquid have its own properties, have its own characteristics on the formation of the meniscus. We say that the water form the concave meniscus, while the mercury form the convex meniscus. That is what we looked on the last session. On our today discussion here, we are going to see how can we identify the upward force of the liquid as we observe here. Kwamba tumeambiwa tuweze kudetermine the upward force. How can we identify that upward force? The thing that we are supposed to understand is on the last session we said that when we take the surface, the upward force is represented by force times the surface tension. That is what we demonstrated on the last session, and we ended that we get that force by explaining it in terms of the mass and also the density. It means instead of putting the force, we substituted the mg. It means density times A times g L. That is what we demonstrated on the last session. On our today here, we are going to see how can we obtain the upward force of the liquid. As we see here that the upward force on a liquid supports the weight of a column of height h above the outside level of the liquid. This presence of the upward force, my dear student, helps us or supports the weight of the liquid of a column of height above the outside level of the liquid. Imagine we have the liquid, my dear student, and that liquid is placed into the container. Now, a presence of the upward force helps us to support the weight of the column of the height. Kwa hiyo inakuwa inasaidia kuweza kusupport ile weight of the column of a height h as we observe here above the outside level of the liquid. Kwa hiyo inakuwa inasaidia kuweza kusupport. It means it weight. Weight tunapokuwa tunazungumzia weight, this is the downward force as we observe here. Now, the volume V of the liquid column is equal to V, which is the volume of the liquid column is represented by the symbol V as we observe here, my lovely students. Now, its formula is pi r square h. Why we say that the volume of the liquid column must be equals to pi r square h, because it extend it occur in the presence of the height. Kwa sababu tunaangalia the amount of the liquid that are found inside the capillary, the rise of the liquid. Kwa amount of the liquid have the tendency to rise at a certain height, and also have the tendency to fall at a certain height, my dear student. Therefore, that is why we say that on the liquid column we identify the volume by taking pi r square h kama tunavyojaribu kuobserve hapa. So the mass m of the liquid column is represented by the volume times the density. Kwa sasa twende tukadetermine the mass of the column, the mass of the liquid column. The mass of the liquid column, my dear student, is obtained from the relationship between the density, volume, and its own mass. We say that density is equal to mass divided by the volume. But here we want to identify the mass of the liquid column. How can we get the mass of the liquid column? We are supposed to cross multiplication or to multiply it by volume on both sides from the formula of the density. Now, if we times it by the volume throughout, we should obtain that the mass must be equals to the volume times the density as we observe here. But we have obtained the volume of the column, which is equal to pi r square h. Now let us substitute at the formula of the volume. Kwa badala ya kuandika v hapa, we are supposed to substitute at the formula of the volume, which is represented by pi r square h. Now, we should conclude by saying that the mass of the liquid column must be equals to pi r square h, then times the density as we are seeing here. Thus, the weight W of the liquid is equal to this one. Now, let us, after looking about the volume of the liquid column, the mass of the liquid column, now let us go and see how can we identify the weight of the liquid column. We know that the weight of the liquid column is represented by the symbol W, as we seen here. The W that standing instead of the weight is D as W, as we seen here. Now we should say that W, which represent the volume, which represent the weight of the liquid, must be equals to the mass times G. It means mg, where m represent the mass and G represent the acceleration due to gravity. But we have the value of the mass. Now let us take this value of the mass, which is equal to pi r square times h density, and substitute into the formula of the weight, which is equal to mg. If we substitute, we should obtain this formula by saying that the weight of the liquid must be equal to pi r square h times the density times the acceleration due to gravity. Now, let us recall from the equation number 6.9. This is the equation that we tried to demonstrate on the last session. On the last session, we said that the upward force, my dear student, must be equals to the downward force, or must be equals to the weight, which is equal to mg. Kwa sasa ndo tutareflect hapa kwa kuambia huyu upward force ambao being represented by the force times the surface tension must be equals to the downward force ambao represented by the symbol mg, as we seen here. Now, as we are supposed to, we tried to demonstrate on our equation number 6.9 that Fy, the force times the surface tension, must be equal to 2 pi r times the surface tension. It means instead of writing this F, we are supposed to substitute which is equal to 2 pi r. Now, if we substitute the upward force, which is equal to 2 pi r times the surface tension, which is equal to pi r square h times the density times the acceleration due to gravity, we should obtain that because the pi r is found at both sides. Now we are supposed to cancel or to divide it by pi r both sides. If we divide, we should remain at the left side by 2 times the surface tension, which is equal to r times h times the density times the acceleration due to gravity. Now we are supposed to make the surface tension as the subject here. If we make the surface tension as the subject, we should obtain that surface tension must be equals to radius to RH density G divided by 2, where this R represent the radius of the liquid column, lakini huyu H represent the height of the liquid column, and this symbol represent the density, even this one represent the acceleration due to gravity. Now, suppose the angle of contact between the liquid and the tube is theta. Now, let us assume that the angle of contact that occur between the surface of the liquid and also the surface of the solid must be represented by the symbol theta, as it is shown on our figure number 6.12. Now, the magnitude of the surface tension y here of the liquid can be determined by considering the component forces, my dear student. So let us end here, my dear student. We should proceed with the next session here.